Fusion Mobile, quality e-learning experience on the go.
All right. Good morning. You are welcome to Fusion Mobile e-learning geography class. My name is Mr. Michael Okoli Peter. I'll be taking you geography, and the topic we are going to handle this morning is map reading. Under map reading, we have scale, size of scale, measurement of distance, map reduction and map enlargement, contour lines, features produced by contours. Map reading is an integral part of geography. In fact, if you know everything about geography and you are deficient in this topic, that is map reading, it makes mess of the whole thing. And map reading, because of the way some teachers handle it in the school, make some students to develop a kind of dislike to this topic, and because of that, some students, just simply because of map reading, they run away from geography class, abandon the beautiful, lovely subject like geography just because of map reading. So this opportunity has provided a platform for you to learn more in detail about map reading. Map reading is very simple. Just follow the techniques, the little arithmetics, I will not call it mathematics, that is involved. Just a step of, the scale, the size of the scale, how to take your measurements. And what you should know is that every step in map reading is taken into recognition. If you miss a step, you have missed a mark. There is nobody that attempted map reading that scores 0. No, not at all. Because each step you take carries a mark. But if you, skip a test, a step, sorry, at the end of the day, you end up maybe not doing very well in map reading. So this morning we are going to look, number 1, what is a scale? Number 2, we look at the size of a scale. Number 3, we look at how to take a measurement of distance on the map, then compare that measurement to the actual distance on the ground. Then we look at map reduction and map enlargement. And we look at some imaginary lines drawn on the maps. We call them the contour lines. Then the features these contour lines produce. In our previous class, we made an attempt to define what map is, and also to look at types of maps. We say that map is a representation of features. The representation of features on what? On the paper. So the actual distance of 2 points on the map, and how you can represent them on the ground, is what scale is all about. And in our previous class, we also talk about the type of scale. Number 1, we have the linear scale. I showed us an example of a linear scale, if you have not forgotten. If you look at this map, this is a cartographic map produced from one of our secondary school in Nigeria. I think this is a mock exam, January, February 2017. This is a cartographic map for a mock exam, January, February 2017. I think it's one of the questions written by geography students in senior secondary school 3 within the FCT, that is ERC, Education Resource Center. Now, this is the map we are discussing. If you look at this map, this is a typical example of a cartographic map. If you look at under this cartographic map, we have a scale. This type of scale is what we call linear scale. If you look at it very well, they are calibrated in meters. We have 200 meters, we have 300 meters, we have 400 meters, 500 meters, and so on and so forth. But if you look at the scale very well, it's divided into two. From this point to this point, we call it the primary section, while from this point to this point, we call it the secondary section. The importance of this scale is simple. You know, some students, whenever you are coming or you are doing map reading, you are supposed to come into the exam or into the class hall with your complete equipment, including your ruler, so that whenever you take a measurement from the map, you can use what you take the measurement to measure your ruler and do your calculation. But some students will not do that. So it is better, it is good we learn how to use this type of scale if you take our measurement from here. Now, in taking measurement, we can use two devices. Number one, you can use a white thread to take your measurement. Then number two, you can use a pair of divider in mathematical set to take your measurement. But preferably, we advise our students to use a white thread so that they can get plus or minus accurate measurement. So that is what we mean by linear scale. Then we now look at representative fraction. Representative fraction scale. That is RF. Representative fraction. And we say that representative fraction is a type of scale that have 1 as denominator and any number as the denominator, but not 1. 1 over 10, 1 over 20, 1 over what? Over 50. And this can be written as 1 is to 10, 1 is to 20, 1 is to what? 50. This type of scale is what we call RF. That is representative fraction. Representative fraction scale. Then number 3 type of scale we discussed in our previous class is statement scale. Statement scale. A statement scale is a type of scale that is stated in a statement form. For instance, if I said 1 centimeter represents 1 kilometer, this is a statement form. I have just made a statement. So this is what we call a statement form. So we have known what scale is. Then the type of scale. We have the linear scale, the one I've just shown you on the map. We have representative fraction scale. Then we have the statement scale. Any of this scale, either representative fraction or statement scale or linear scale, you can be asked to convert one form to another. We'll do that as we proceed. But let's look at what we have here. Then let's look at the size of a scale. The size of a scale determines the size of a map. The size of a scale determines the size of what? The size of a map. Now, if we have 1 is to 10, or 1 over 10, 1 over 20, 1 over 50. These are examples of what? Representative fraction scale. If you have a map and you have this, maybe you are asked to categorize a map according to their size, and you have a scale 1:10, 1:20, 1:50. What we normally tell our student is this: when you are dealing with the size of a scale, there is this, we call it fact, undisputable fact, that we need to have at the back of our mind, that the larger the scale of a map, the larger the scale of a map, the smaller the map. Yeah, we are looking at the size of a scale. I give you an example. We say this is 1:10, 1:20, 1:50. You may be asked to arrange this scale either in ascending or in descending order according to their size, either from the smallest to the what? To the largest, or from the largest to the smallest. This is 1, 2, 3. We say that the larger the scale of a map, the smaller the what? The smaller the map. And the smaller the scale of a map, the larger the what? The larger the map. We should have that at the back of our mind. For instance, if I want to draw a map to this scale, with what I've explained now, we are going to discover that 1:10, the scale of 1:10 maybe will be like this. 1:20 maybe like this. 1:20. Then 1:50 will be like this. 1:50. That shows that the smaller the scale, the larger the map. Look at this. We have 1:50. Look at the map coverage. 1:20. Look at it, and 1:10. But if you look at it on a normal ground, 1:50 is bigger than 1:10. But when you are dealing with the size of a scale, we are looking at the scale as per the size of the map. So 1:10, the map of 1:10 is larger or bigger than 1:50. If you have this at the back of your mind, when you get to measurement of distance, you can now apply this formula in taking measurement. For instance, when you have 2 points on the map like this is point A, this is point B, and you are asked to calculate the distance between point A and point B by using what? Using your scale. So that is why knowing the size of a scale is very, very important, because it will help you to solve the what? The measurement of distance on the ground. So that is all about the size of the scale. Now let's look at the measurement of distance on the map. I've started already, but let me put more explanation to it. When we talk about the measurement of distance on the map, our interest is if point A and point B is, for instance 5 centimeters, that is the distance between point A and point B is 5 centimeters. What is the actual distance if these 2 points were to be on ground, point A, point B? How will you convert these 5 centimeters to kilometer? You know, that is what measurement of distance is all about. And we are going to solve, 1 or 2 examples. Then we move to map reduction and map enlargement. But in all this, please have in mind the size of your scale. the larger the map, the larger the map, the smaller the scale. And the smaller the scale, the larger the scale, sorry, the smaller the map. You can see 1:20 is bigger than 1:10. On a normal sense, you may think that 1:20 maps should be bigger than 1:10. No, not at all. Because by the time we get to map reduction and map enlargement, when you enlarge or reduce map, it's going to affect the scale. Because in many exams, examiners, they do ask, extract map of this to a scale of this. So if you don't know the size of your scale, as a student, as a candidate, you may be confused. What are they actually saying? Are they telling you to reduce, or they are telling you to enlarge? So before we get there, I want you to have this at the back of your mind, so that when we get to map reduction and map enlargement, I'll now be referring you to the size of your scale. But now let's look at the measurement of distance on the ground. What are the procedures? What are the procedures? Now let me clean the board and draw a map to a certain scale. Then we'll now measure it and see how we can find the actual distance of that 2 points, on the ground. Let's look at it. This is a map, for instance. This is a map, and the map here, the scale is 1:50,000. This is the scale. This is the representative fraction scale. You can write this one as 1/50,000. Then you have, this is a river. This is B. This is river A. From point A to point B. Let's say this is River Kaduna. And when they want to make it simpler for you, they may ask you what is the distance. They can give you the distance on the map. They say between point A and point B of River Kaduna is 12 centimeters. What is the actual distance of it on the ground? That will be very simple for you, because they have given you the measurement already. But a situation where you were not given the measurement, you are asked to use either the pair of your compass or a pair of dividers, and or your thread to take the measurement from here, then use the same measurement to do your conversion. That is why when we started, I told us that in map reading, each step is very, very very important. I'm going to handle it this way. Okay. Now, this is a distance between 2 points, point A and point B. At times, it may be a straight line. If it is a straight line like this, point A, point B, there will be no need of using thread. But in this case, we are looking at this distance. This is a river Kaduna. You don't expect river to move, in a straight direction. It has to meander. That is one of the characteristics of a river. So because of that, we are not talking about this one now. We are talking about this one. What you do is this. This is a thread. Now, this is my thread. I'm going to use it to demonstrate how to take this measurement. The first thing you should do is hold your thread like this and let some part of it be in your hand. Take your biro or your pencil and mark a point, so that as you are doing your measurement and you leave your hand, whenever you remove the thread, you should know where you start from and end it. So this is my own. I've marked it. So what will I do? I'll put this marked here. Then I'll hold it. I'll begin to trace it like this. You can see I'm leaving my hand. That is the importance of marking this point, so that whenever I remove the thread, I'll know where I start from. Can you see? You hold it. It's very interesting, just like you are doing a child play. Can you see? You are taking the measurements. Can you see? When you get to the end, you hold it and mark it again. So you know where you start from and you know where you end. So you can see, I know where I start from, and I know. That is why using white thread is more advisable, because white thread, anywhere you marked it, it will be very visible. You hold it and bring it to your ruler, your wood. You know, we advise students to use wooden ruler, that yellowish color ruler that we use it when we're in primary school. That one is more advisable. Okay, now you can see, let me repeat it again. I want everybody to follow me. Take up your white thread, look at my own, and follow me, because I'm going to use your own measurement to do the calculation here. I'm not going to use my own. Because when we are talking about map reading, it's practical. It is not theory. As the teacher is teaching you, you follow the step. You follow what he's doing. Then you do it together. That is the only way you can understand map reading. So everybody should remove his white thread and draw a map in your exercise book. Get me a line like this from point A to point B. Don't mind the distance, no matter. Just take a line like this. Mark point A and mark point B. Bring out your thread as we are demonstrating it now. Let me start again. What did I say? The first step is to do what? Bring out your thread and mark a point. You use your what? Your pen, so that whenever you remove your hand, that place can be visible. So you put it like this, the edge, and begin to do your measurement. Everybody should follow me the way we are doing. Continue to follow me, because I'm going to use your measurement as I said. Then can you see? It's like we are doing a kindergarten work here. I hope it is very interesting. Can you see? To this point, I remove my own, I mark it. Now you have removed your own. Look at my own distance. Use your distance and bring out your ruler. Bring out your ruler from where you start to where you end. What do you think? What is the measurement? Okay, thank you. 47 centimeter. 47 centimeter. That is point A to point B. Is equals to what? 47 centimeter. Now, what is the actual distance if this river were to be on ground, or is to be on ground? Now, what do you do? Follow me, look at it. You now multiply 47 by the scale of the map. The scale of the map here is what? Is 50,000. Is 50,000. Then divide by 100,000. Do you know why we are dividing it by 100,000? You know, in your metric system, 100,000 centimeter is equals to 1 kilometer. You know, when you are measuring a distance, the unit of a distance is in kilometer. Now we use centimeter here because there is no way you can get your centimeter on the map. So to convert this centimeter to actual distance on the ground, you have to divide it by what? By 100,000. Multiply 47 centimeter by the scale of the map all over 100,000. What will it give us? This one will go like this. This will go. 47 multiplied by 5 is what? 47 multiplied by 5 is what? Nobody? You don't have calculator? 47 multiplied by 5. 235. Good. over what? Over 10. Divide it by what? By 10. Think you have 20. The answer is what? 23.5 kilometer. Can you see? So the actual distance between point A and point B, the distance of River Kaduna between point A and point B on the ground will be what? 23.5 kilometer. But on the paper it is 47 centimeter. I think this is how to calculate, you know, distance on the map using the scale. Using the scale. Now, before we leave the measurement, let me explain something to us briefly. I think you follow me to the point we get this 23.5. So when you get home, you can pick any distance yourself, follow the step and solve it. Or before we even finish this topic this morning, I'll give you some take-home assignments that will help you to get more understanding on how to calculate distance between 2 points on the map and to find the actual distance on the ground. Please, in map reading, any step taken must be what? Must be documented, because I've told us that in map reading there is no zero. If A to B is equals to what? 47, as we have here, write A to B 47. You have scored 1 or 0.5. It's a mark. If this multiplied by this is equals to this, you have gotten your own. Divide by this. Follow every step and let all the steps you have taken be documented until you get to the final answer. You know, in map reading, we are not interested in the final answer. We are interested on the step you take before you get to the final answer. So let us have that one at the back of our mind. Now let me come back here again. This is the map. Can I clean this side? Okay. Now look at it this way. This is River Kaduna, 1:50,000. At times, they will ask, we are taking this to go to map reduction and map enlargement. The purpose of map reduction and map enlargement is there are some features that are present on the map given, and they want you to reproduce these features in the map that you are going to copy or you are going to produce. So that is why the issue of map enlargement and map reduction is very important. For instance, this is a river A, River Kaduna, between point A and point B. They will ask you, now extract this map. This map to a scale of what? 1:100,000. Okay. Now let's look at map reduction and map enlargement using the same example that we have on the board. Look at this question. Extract this map. We are talking about this map to a scale of 1:100,000 and insert the River Kaduna, that is this River Kaduna, on the old map. Now there is something you must understand. If you are asked either to reduce or to enlarge, remember that the map that is given, for instance, if is this map we are referring to, if is this map we are referring to, if is this map has a scale of 1:50,000, and this river is River Kaduna from point A to point B. Can you see it? This is the map we are talking about. This river, this green line on the map, we use green to represent river and vegetation. So this green line is the river we are talking about, River Kaduna. Okay, sorry, blue line. Thank you very much for that correction. This blue line is the river Kaduna from point A to point B. Now, you are asked to extract this map to a scale of 1:100,000 and insert this river in your new map. So what you should know first is that immediately this question is given, this map is now become your old map. Is the map that you are going to produce now that is now your new map. Number one, the scale of this map becomes your old scale, while the scale you are given 1:100,000 becomes your new what? Your new scale. Then remember what we said when we're talking about the size of a scale, that the larger the scale, the what? The smaller the map. And the smaller the scale, the what? The larger the map. Now, if you compare the new scale given to you, that is what? 100,000 and 50,000. You should remember that 100,000 is bigger than what? 50,000. So since 100,000 is bigger than 50,000, you are going to reduce the map. And how many times are you going to reduce the map? What you do, you divide the new scale all over the old scale. If you divide 100,000 by 50,000, you are going to get 2. So in doing that, you pick your ruler and measure the length and the breadth. From this point to this point, maybe is 10 centimeter. From this to this, maybe is 6 centimeter. Now, you know that if you divide this by this, it's going to give you what? It's going to give you 2. So, the length is 10. 10 divided by 2 will be 5. So, you pick your ruler and get a new map. Let me clean the okay, let me 10 divided by 2 is 5. Pick your ruler and draw 5 centimeter. Then the breadth is 6 centimeter. 6 divided by 2 is equals to 3. So you are going to have 3 here. Then this is now your new map. Bring down your scale immediately. 1 is to what? 100,000. You have now reduced this map. You have done what? You have reduced the map. The next thing is, how are you going to insert this? There are ways we can do it, but the simplest way is what we call the grid system. Grid. You divide your old map into what? Into grids. You place your ruler from here to here. From here to here give you what? 10 centimeter. If you divide centimeter into 2, you are going to get, this is 1, 2, 3, 4, then 5. And you can also like this, like this, like this, and so on and so forth. Now, you can see this. You know that this map, this one is twice of this. So anything you are going to do here, it will be what? Less than 2 of this. So if this one is from here to here is what? 2. From here to here is 2. Here to here is 2. Here to here is 2. What will be here? Then your own. You are going to divide your new map into grid again. But this time around, it's not going to be 2 centimeter. It's going to be what? 1 1. Because this map, if you divide it into 2, will give you this. So anything you do here is half of this one that you are going to do in your new map. Now you divide your own into 1 centimeter, like this, like this, like this. Then you have this, this, and this. Now you look at, you count 1 2 3 4. You count 1 2 3 4. This start here. Where will your own start? Your own is going to start this place. That is point B. You trace it. Okay, point A, sorry. This is point A. You look at it. It goes like this to the second box here. It goes like this. And it ends here. You put your point B and write river what? Kaduna. You have number 1, reduce the map to a new scale. Number 2, you have insert the river A, river Kaduna from point A to point B. That is it. So that is how to reduce the map. You know, in most exams, what the candidate or what the examiner normally tells the candidate to do is to reduce the map. For instance, if you have this map, this is a map, there is no way you'll be told to enlarge this type of map. There is no way. There is no way you'll be told to enlarge this map. It is practically impossible. But you can be asked to reduce this map to either 3 or 4 times the original size. So that is why we are concentrating more on map reduction than map enlargement. So what are the steps? Number 1, you look at the scale given, the new scale given to you, and the new scale is always in the question. If you look at my own here, I said extract this map to a scale of 1:100,000. 1:100,000 becomes my new scale. Why 1:50,000 becomes my what? My old scale. The next thing is to divide the new scale by the old scale. If you divide 100,000 by 50,000, it's going to give you 2. That shows that if you take the measurement of the breadth and the length of the old map, we are going to divide it by 2. Everything done here will be divided by 2. That is why from this point to this end, that is 10. 10 divided by 2 gives me 5. So the length of my new map will be 5. From this to this is 6. That is the breadth. Breadth divided by 2 will be 3. So the breadth of my new map will be what? Will be 3. Then immediately you finished it, lest you forget, you bring down this new scale under the new map. Then when you come to inserting any features, it can be settlement, it can be a spot, it can be a trigonometry ratio, it can be anything on the map. You are asked to replicate that features in your new map. What you do, the best way to do it, you divide the old map into grids. At times, a map like this, they may cut a portion of it and ask you to enlarge and bring the features from here to your new map. What you do in a case like this, you do not divide the whole of the map. you should be given. For instance, you are given here. So in dividing the grid, the map into grid, you don't divide the whole map. You divide the one that concerns the features that you are asked to replicate in your what? In your new map. For instance, look at this map. Here we have the whole of the map, but there is a section that is mapped out here. Look at point A, point B, point C, point D. Okay, we have point A, point B, point A here, point B here, point C, point D. Then we have a river. If, for instance, you are asked to enlarge this type of map, you are not going to concern about the whole of this map. Your concern is this mapped out area. So A, B, C, D. But remember, you are going to use the scale of this old map as your old scale. Then when you are inserting, you are producing a new map, it will now carry the old scale, the new scale according to the equation given to you. So here, what you do, for instance, if you are to insert this river from this point to this point, you are going to divide this into grids from this point to this point, and not from this point to this point, because from here down here and from here down here is outside the equation that you are asked. So we have to be very, very careful anytime we are given map. Map is very interesting, but you have to be very, very careful and be very, very diligent. So that is how to reduce, and that is how to enlarge. To enlarge the map is the opposite of reduction. What you do is that what you are asked to enlarge the map, instead of dividing the new scale by the old scale, you divide the old scale by the new scale. It will give you a fraction. That shows just to tell us that you are going to, you know, enlarge the map to the number of that thing given to you. So that is what we mean by map enlargement. Map enlargement is not common, but for us to know that there is map enlargement, that is what you should do. Then let's move ahead to contour lines. Let me use this, or no, let me use our new map now and give you this map to enlarge, and give you this map to enlarge. Now extract this map here, 1 is to 100,000, to a scale of 1 is to 25,000 as your assignment. If you understand map enlargement, you have also need to understand map reduction. You need to understand map enlargement. So use the knowledge of map reduction that we have done here, reverse it, and enlarge this map. Look at the scale here, 1 is to 100,000. Here 1 is to 25,000. So give me, if you can enlarge this map to this scale. In our next class, I'll see what you have done before we move to contour lines. Okay, we are talking about contour lines. Contour lines can be defined as an imaginary line. Imaginary line drawn on the map. Imaginary line drawn on the map. Okay, imaginary line drawn on the map, joining places of equal height above the sea level. We call them imaginary lines because you cannot see them. I gave example in one of our meetings some time ago that some of us, we go to church, we go to mosque to go and worship a deity, a supreme being that we have never met, and we talk to him. Some of us, we even dance and sweat to somebody that you've never seen, but your faith so much carry you that you believe that this being exists. If you have that belief and you so much, you know, attach to that your belief, I also want you to believe what we are going to say here. We are talking about contour lines. We say that there are imaginary lines drawn on the map joining places of equal height above the sea level, and they are represented like this. You find them all over the cartographic map. Now, this is what we call contours. We call them contours. They are numbered. These can be 100, 200, 300, 400, 500, 600. So what this is telling us is that anywhere you see this line, any place it touch, like here, if you trace this contour down to this numbering, that shows to us that this point is 400 meters above the sea level. You look at this point, this one is 100 meters. So if you trace the contour anywhere it touch, it shows that that point is 100 meters above the sea level. So contour lines can be given to us, and we may be asked to find out what are the features that this contour line has produced. At times, a contour line like this, a river may pass, and they will ask you what is the direction of river A. This is river A. They will ask you what is the direction of a river. Or it can be from here down here. They will ask you what is the direction of this river. Is it flowing towards the eastern part, or is flowing towards the western part, and so on and so forth. So what we should know is that contour lines give us, you know, if you look at 100 meters above the sea level and 200 meters, you can now, you know that 200 meters is higher than what? 100 meters. And any river you see on the surface flow from the upland down to the lowland. For instance, we talk about River Benue. River Benue originated from Cameroon Mountain. We talk about River Niger. River Niger originated from Republic of Guinea, that is Futajalon Mountain. If you talk about River Donga, River Donga in Taraba State originated from the North Central Highland. If you talk about River Kaduna, the same thing. So any river you see originates from an upland. So if you see a river on a map like this, can you see? See this green line represents this blue line represents a river, and you may be asked to identify the direction of flow of this river. Identify the direction of flow of this river. If you can see, here is a contour line that is very, very compacted together. Now, the steeper the contour, then the higher the place above the sea level. What I mean by this is that, let me clean this and demonstrate what I've just written on the board. When you have a contour line that's so Then you have another one like this. What this place is telling us is that this is a highland, because the contour lines here, there is more closely compacted. You have a steeper, this is a steep slope, this one is a gentle slope. So if you have a river, for instance, that flows like this from here and goes down, and you are asked what is the direction of flow, use the arrow to tell us the direction of flow. You know that this place is so compacted, it's so steep. The slope here is steep, while the slope here is what? Is gentle. The same contour. But what happened here is that because this place is steep, that shows that the steeper the contours showing us, it's telling us a land features that is being produced, and this land features is known as the highland, either a mountain, either an upland, either a plateau, or any upland. And you remember, as I explained to us, the river originated from an upland. So let me bring this map again and show us an example. Look at this. We have this river. This is River Kaduna, and here you have a river. You may be asked, what is the direction of flow of this river? The direction of flow of this river. Remember, this is the north, this is the south, this is your west, and this is your east. Sorry, this is your west, this is your east, this is your north, this is your south. Now, can you see what I'm demonstrating? Can you see these contours closely compacted here? What does it tell us? It shows to us that in the southern part of the map, or the eastern part of the map, you have an upland, either a mountain, a plateau, or whatsoever. And because of this river originated from the south down towards the northern part of the map. Can you see? That is what I'm telling us. Why do we say that? We say that because of these features here. Coming to this place, you have a settlement. This is the place that the river passes. Can you see? Down to this place. People do not normally settle on top of mountain. That is why you see that the settlements are majorly located towards the north, western part of the map. But if you go towards the southern part, you can see that we have the presence of contours that are closely jam-packed, and even you see some traces of rivers that originated from this upland, entering into this major river and flow up north. So if you are asked to tell us the direction of flow here, the river is flowing from the south towards the northern part. So it is the knowledge of contours that will tell us the features that are produced on the map. It can be a plateau, it can be a mountain, and it can tell us, the direction of flow of a river. And if you give this map, for instance, if you give this map to a layman, a non-geographer, he will tell you that there is no way the river will flow from the south towards the north. But with the knowledge of what we have studied now, if you pick any of this map and you look at the presence of rivers, the first thing that will come to your mind is what is the direction of flow of this river. And for you to know the direction of flow of this river, you look at the contour lines, the way they are arranged. Are they closely packed like this, the way we have them here, or they are gentle like the way we have them here? The closely packed contours depict something. What does it depict? It depicts that we have an upland in this environment. Then this one, we have a gentle slope, either a plain land because of the distance. Remember, when we define our contours, we say that it's an imaginary line that is drawn on the map, joining places of equal height above the sea level. So that shows that the distance between this and this, is wide. Therefore, make this place to be a plain ground compared to this place that are closely, packed together. That is to tell us this environment is an upland, either a mountain, a plateau, or any other, features. But here is a plain, and or it can be a level land. So with this knowledge, you can carry your map and number one, tell us where some of these features are, and they can tell you there are some settlements most at times that can be within, or on the foot of a mountain. They'll tell you what are the functions of this settlement. What are the functions of this settlement? If you look at this map, here we have a river and we have a settlement down here. They'll ask you from the map, settlement B, can you give us 3 functions of this settlement? If you see any settlement located very close to a river, what do you think should be their function? Number 1, fishing. Number 2, agriculture. Because they can use the river for irrigation, they can also use the river for what? For fishing. So, map reading in geography is very practical. Just follow the direction. Just follow the instruction given to you by the examiner or by your teacher. It is very simple. It is very direct. It's something that without much guidance, you can on your own sit down, do the practice, and you get it understood. If you understand map reading very well, you are 20-25% sure of a credit pass in either WAEC or NECO in geography, because it's compulsory and the question is every year. There is no geography exam, either NECO or WAEC, that will be complete without map reading, and it's not optional, it's compulsory. So that is all about the contours and the features that can be produced. So I urge you, as you go home, you pick your map, any cartographic map like this, look at the scale given to you, look at the question, are you going to reduce, are you going to enlarge, what are the features in the map that you are asked to insert in the new scale, in your new map, can you do it? I've explained to us how to do it. Go back to the note again and read it again and pick some map, a map either, this one is January, February, this one is January, February 2017 mock exam in FCT, Federal Capital Territory, Abuja. They use it for their mock exam. So look for a map like this, or contact somebody who has written WAEC or NECO in geography. Get the map from him and go through it. It's as simple as A, B, C.